Hey guys, welcome back to the channel. I know it's been a while since I posted any videos. Been moving around, a couple of life changes for me, but hopefully we get back on track here. I got a lot of projects to get through. As you can see, it's kind of a dirt field we're standing in behind my house. We're going to talk about this trailer today, but I have a lot of other projects. I don't know if you can see the orange stick back there, but that's going to be a reference. That's kind of reference for the height of a shop I'm going to be building. I picked up a really cool cement mixer, you know, old, rusted, found it in an estate sale. Grandpa had it in the backyard, nobody ever used it. I'm going to kind of refurbish that thing and use it on some of the projects, like putting up fences and whatnot. But anyway, let's get to today's video. We're going to go over these trailers. I built two of them. Just the basics on how to build a trailer. Not in depth or anything. You know, we're not doing engineering class or any of that, but we're going to go over the basics of building a trailer. And there's really just two or three things to consider to make a functioning, strong flatbed trailer such as this one. You want to start out, obviously, by making your deck as flat as possible. No corners turned up or anything like that. You don't want the deck bowed, you know, just a nice flat deck. The second thing is going to be the squareness of your tongue or coupler to the center line of your trailer, as well as the center line of your hubs or your tire faces. And then the third thing is going to be tongue weight, and that's going to be based off of your center of gravity of your trailer and where you place your axle. Go over the components of the trailer really quick. Obviously you have the frame. This one is made out of 3x2 eighth wall rectangular tubing. All the sides are 1.5 inch angle iron. The gate is a 4 foot tall by 7 foot wide. It's also made out of 1.5 inch angle iron with the number 9 expanded raised sheet metal that you can see on there. The coupler is just a 2-inch ball with a hand wind jack that is capable of up to 2,000 pounds. And then we have the axles and the springs and the tires. The axle is a 3,500 pound axle. It's a 96 inch hub face to hub face axle. I have two 1,750 pound springs, one on either side, so that equals the same amount as the axle, 3,500 pounds. And then the tires are rated at 1,820 pounds at 50 psi. So all the components are at least 3,500 pounds or more. So let's start out with the deck. The deck is pretty simple. You just need a square structure that is capable of holding whatever you're going to put on it. I have 5 cross members that run the length of the trailer, along with the front and the back. And in total length, I built this a while ago, so I don't remember exact numbers. Total length, this is exactly 13 feet long and exactly 7 feet wide. Now you ask why I didn't make it 14 like some standard trailers. And that's because I had 20-foot sticks of material to work with, and I wanted 7 feet wide for a lot of the UTVs out there, and most of them will fit on a 13-foot trailer. At the time I had a Polaris General, and that's why I built it to that size. So you want to start out by making sure that your deck is flat. I did that. I picked up just some cheap RV jack stands, kind with a screw in them. And I took two 8-foot 2x4s, and I just connected those to the top just with a couple of screws from the bottom. And that way I had 4 corners that were all adjustable. Using that, I was able to create a level surface to work on. I was also able to adjust all four corners, all four sides for level, and take out any warp basically in the frame as well. So my frame, I cut all of that with a little Yes welder that I picked up off of Amazon some time ago. And when I bought all the material for the two trailers that I built that are identical to this one, I cut all the material at the same time, and I used that little Yes welder for all of the frame material. I notched out all these corners right here, the 45-degree angle cuts, the tongue. Back here, there is a 25-degree notch out of it, so that I could bend that so that the tongue would come out at the correct angle for the coupler that I put on here. All the sides and uprights and gate and everything, I just used my small bandsaw to cut everything to lengths for those. Placed the frame on that little setup I had with the RV jack stands, and I just used a level along both sides in the front and back, and I just adjusted it till all of them were level, and that basically makes sure that I'm not warped. It just gets me on that same plane. And then I tacked the frame in place. Now there's another method you can use that if you don't have something that's adjustable like that, you can tie strings from the corners and run them from corner to corner. And when those strings touch in the middle, you know that the corners are level. And so I'm going to show you on a box here, either down in the corner, or I'll just explain it in a cutaway video. Those are the two methods I've used. If you know of another method, let me know down in the comments. So to demonstrate the string trick, if you've never seen it or never used it, if you imagine this being your trailer frame when you start out, and you can use this for any level or planar surface, and it works good or better than the level when your four corners aren't connected, like each individual corner is floating. So you can see they just barely touch, and if you were to reverse them, they do the same thing. They just barely touch. You can tell that all four corners are on the same plane, they're level. Even if this is tilted, you can see that all four corners stay on the same plane. Now if you were to mimic the sides of the trailer being up in either direction, by squeezing it, you can see that that string goes slack, or in this direction you can see it doesn't touch the bottom anymore. And that's why you want to trade the strings, do one underneath and then trade the other one, because even though you see some slack there, if you were to trade them, you might see more slack because they're not touching. You'd be able to tell even better. So do it one way with one on the bottom, and then the other way with the other on the bottom, and that, like I said, will show you that your four corners are equal. And like I said, no matter what, if they're tilted, it will always show that these four corners are on the same plane. I then took all my cross braces that I had cut and I just tacked those in place. I just used I used actually one of these sides, and I just clamped it to the bottom on both sides and just sat the cross member on there, measured it out, tacked it in place. And I did that all the way down the frame till all 5 members were in. And then I just did a couple of stitch welds on the cross members, on the corners, basically just to solidify it, so that it wouldn't, if I bumped it or shifted it, it wouldn't be out of square, start to warp or anything like that. Up to that point, it didn't matter which was top and which was bottom. I mounted the tongue at that time on the top, because it's harder to hold those big pieces up and without gravity pulling them down. And So I could clamp them down, I could adjust them, everything like that, tack them in place. This is where you want to make sure where your coupler is going to end up is going to be on the center line of your trailer and square to it, basically. So without the axle in place, the easiest way that I've done this is just off of the corners. And you're going to measure off of the corner just to the center of your ball, or the center of your coupler. And my coupler wasn't welded on at the time. I just used some clamps to hold it in place while I measured. But from that corner to the center of the coupler, and this corner to the center of the coupler, you want to make sure that those are equal, and that's going to put you right in the center of the trailer with your ball. Even if you're shifted a bit with your lengths here, with your legs here, you're still going to be on the center line. And you're going to want to make sure that you're out far enough. And on this one, I'm out 42 inches, because eventually I'm going to mount a metal box there. But you're going to want to make sure that you're out far enough that when you are turning or backing your trailer up, it's not going to hit the side of your vehicle. I usually find that with these wider ones, about 42 to 48 inches is the best. On smaller ones, you can obviously go shorter, but the 42 inch from the front of the trailer, and then those matching or equal measurements from the corners to the center of your coupler. That's going to be one of the measurements you want to make sure you get correct. That's going to affect the way your trailer tows. So at that point, I did about a 75% weld out on the frame. I did all of the cross members. I did all the welds on the tongue that I could see. And it's also easier when it's like that to do the welds that are going to be on the underside when you're done, because at that point I needed to worry about finding my center of gravity, because that's going to tell me where I want to place my axle for the amounts that I'm going to place on this trailer. Now I do that with a second pair of jack stands, because the frame is still resting on those 2x4s and RV jack stands that I have. And then I've got a second pair of jack stands that I use for everyday shop stuff that lift pretty high. And I will place those under the frame and lift it just enough that it's off of those 2x4s so that it doesn't really fall. It's not dangerous or anything. But I'll lift that up and I'll adjust those back and forth until that trailer frame is perfectly balanced. I can put a finger on one end, it'll go down really easy. I can put a finger on the back, it'll go down really easy, and it's just perfectly balanced. From where I figured that balances perfectly to the center of my ball, or the center of my coupler, is going to be my center of gravity. And the center of gravity is always going to end up in front of your tires or in front of your axle. Now, I don't remember my exact center of gravity on this one. When I built it, it's been a little bit. This is the part where a little bit of math comes in. A good rule of thumb for tongue weight is going to be, on smaller trailers, you're going to want to start closer to a 60-40, which means 60% of the weight is on your axle, 40% of the weight is on your tongue or your coupler. The bigger the trailer, that's going to start to change to around an 80-20, and depending on how big that trailer is, it could go down even more to where your axle is carrying 90% of the load and your tongue is only carrying 10%. My trailer, with the 3,500 pound components that are on it and minus the frame weight, has a rating of around 2,700 pounds. With 2,700 pounds, I wanted enough tongue weight that if I had the load a little bit behind the axle, I wanted a bigger split so that more tongue weight would be on the front. So if you load, I'll put up a quick video here to show you the importance of tongue weight. If you load a trailer incorrectly and you have most of your load behind the axle, you're going to get sway, and it's going to be bad. It's not going to be good. If you've ever experienced it, it's a bad thing. I wanted a good amount of tongue weight, and I've got mine right between 700 and 800 pounds of tongue weight. My axle is at 12 feet from my coupler, that the ratio works out to be right around 75, 77. Like I said, I don't remember the exact measurement of my center of gravity, but I do know that I figured right between 700 and 800 pounds of tongue weight, and it'll haul around 2,700 pounds. All right, now you figured your center of gravity. You found out what that is. For ease of numbers, let's go with just a 2,000 pound trailer. That's going to be your rating. And you want about 500 pounds of tongue weight, which isn't a lot, but it's still it's enough as long as you load your trailer correctly. It appears the troopers are headed off somewhere. What you're going to do when you decide how much tongue weight you want, you're going to do some math. You are going to basically take your center of gravity, and you are going to divide that by the percentage that you want on your axle. All right, you have a 2,000 pound trailer. You want 500 pounds of tongue weight. Now, if you do simple math, that's 75-25. That means that 75% is on your axle, and 25% is on your tongue. So with that split, you would take your center of gravity number, the measurement that you figured out, and you would divide that by the 75. And that will give you your center of axle measurement, where you want to have your axle. And that will always be behind the center of gravity. You will never be in front of it. Wherever you buy your components, they are going to tell you or give you a measurement of your leaf spring eye-to-eye measurement, and they're going to give you a leaf spring front eye to center of axle measurement. Okay. Now you can do some math and figure out where that is. I just mount the axle to the springs for the time being. And I will put the springs into the brackets, the front brackets at least, and I will lay that just on top of the trailer frame, and I will measure out my coupler to axle measurement. Now your tongue weight being the third important thing, part of that is making sure that your axle is square to your trailer and square to your coupler. Just like we measured from the coupler to the corners of the trailer to make sure the coupler was square, we're now going to square the axle, this is your hub, to the coupler. And we're going to measure just like we did, the center of the coupler to the center line of this hub. You can measure to any part of the hub, but make sure you use the same spot on both sides. I use the hub face, which is where the tire is mounted to, the center line of the hub face to the center line of the coupler. And that creates a triangle from your coupler back to your hub faces. Making sure that those are equal is going to be paramount to make sure that that trailer tracks correctly. Now, in all of the literature I've read, they say that an 1/8 inch tolerance is where you want to shoot for. I shoot for a 1/16. The more accurate that measurement, the better, because that's going to affect your tire wear as well. If it's not square, your trailer might pull, but it's going to wear your tires really fast. We have made sure that our deck is square and level. We have made sure that our tongue and our coupler is square to the trailer frame and center line of the trailer. We have figured out our tongue to axle ratio using the center of gravity, and we have made sure that the axle is square to the coupler. After that, what you do to this trailer, the only thing that's really going to affect it is how much steel or guarding or anything you put on it. It's going to affect the weight rating. It could also affect the balance of the trailer. Like, I've got a big gate back here. And I actually place the components on the rear of my trailer to find that center of gravity, so it doesn't have that much of effect on my trailer. But if you didn't take that into account while you were building the trailer, you could very easily cause your tongue weight to be less than what you want. Otherwise, just make sure you do things equally. Like this 1.5 inch angle iron, it's pretty much equal on the amounts that are placed everywhere around the whole trailer frame. So it's not going to affect my center of gravity very much. It's going to affect my trailer rating because it's extra weight that I've added to the trailer. Every piece of guarding or railing that you add reduces the weight that you can load on the trailer. Alright, so you've built your trailer, you're ready to go. You've added your safety chains, you've wired it, you've got your lights on it, everything. Let's talk about loading a trailer really quick, okay? If you have a trailer that has a 2,000 pound rating, if you put a 2,000 pound block of cement right above your axle, that is going to put 500 pounds on your tongue, and 1,500 pounds on your axle. It will tow pretty good like that. If you shift it forward 1, maybe 2 inches, you're going to add an extra 100, 150 pounds to your tongue. That is not a bad thing. The coupler I placed on here has a 1,000 pound weight rating. The front jack has a 2,000 pound weight rating. As long as you keep the weight on your trailer below or at what it's rated to carry, the more forward you carry it, I don't want to say safer, because if you put 2,000 pounds right here, it's not going to be safe. Because what I mean by that is always err to the side of putting a little more weight forward. So when I hauled my Polaris General, I always backed it on because the engine was on the back, and that would put a little more weight forward onto the tongue, and it just towed so much better. Now if I pulled that General on here and then I backed it up to that gate and so that I could load things on the front of the trailer, it didn't tow as well. It still towed okay, but it did not tow as well. I don't know the entire mechanics behind it or the physics, but I know that it will cause your trailer to sway. It'll put you in a dangerous situation. Make sure that when you build your trailer, you build it with enough tongue weight to make it travel safely, even when it's empty. And then when you load it, make sure you are loading it correctly. Alright guys, I think that just about covers everything. If you have some questions, shoot them down in the comments for me. Like, subscribe, and we'll see you on the next video.